On this 2020 to 2025 F250 with the 7.3 gas engine, P0562 is a low charging system voltage fault. In plain terms, the PCM is asking for a charging voltage, but the voltage it sees is too low compared to that request. The truck may act like it has a weak or discharged battery, a charging warning may come on, or electrical loads may pull the system down. The possible fault areas are broad: battery condition, fuses or fusible links, generator output, the battery monitoring sensor, PCM power and ground circuits, and the wiring, terminals, or connectors between them. For P0562, the code sets when voltage drops 1.5 volts or more below the generator voltage desired, calculated by the PCM after 30 seconds. Before getting into the electrical checks, make sure battery voltage is greater than 12.2 volts prior to and during this pinpoint test. Also, do not have a battery charger attached during vehicle testing. Start with the obvious items. Inspect the feed system. Look for abnormal ignition off current drains. Inspect the battery. Inspect the high current BJB for loose, damaged, or corroded connections, and verify the mega fuse, rated at 275A. If you find an obvious physical cause, correct it before moving deeper into the diagnostic path. Next, run the PCM self-test and look at the other charging, battery monitoring, and charging system communication faults that may be present with P0562. Do not treat those as background noise. If those related faults are present, take the diagnostic path for that fault group first. If those faults are not present, continue with the P0562 voltage checks at the generator. With the ignition off, disconnect the generator connectors. Inspect for corrosion, damaged or bent pins and pushed out pins. Reconnect them and make sure they fully seat and latch. Then measure voltage at generator C102B pin 1 using the correct circuit connection points. That voltage should be within 0.5 volt of the recorded battery voltage. If it is not, tighten or install a new generator B+ nut as needed. Verify the high current BJB Mega 2 fuse, rated at 275A, is OK, and repair the affected circuit as needed. Some of these voltage measurements depend on exact connector lead placement. If the lead placement is not clear at the vehicle, pause, verify the earlier diagnostic path and the connector identification, and avoid guessing. If generator B+ voltage matches the battery closely enough, start the engine, turn on all accessories, and use the scan tool active command to command GenVs to 14.5V. Measure voltage drop at the generator B+ circuit while performing a wiggle test on the generator wiring and connections. Use a current clamp to record current, then divide voltage drop by current, V over I, to calculate resistance in ohms. If resistance is greater than 0.3 ohms, inspect and repair corrosion or connection problems in the generator B+ circuit or positive battery cable connections. If resistance is not greater than 0.3 ohms, move on to the battery monitoring sensor check. Inspect the battery monitoring sensor, then turn the ignition on and run the PCM self-test. If the battery monitoring sensor fault is present, turn the ignition off, disconnect BMS C1689, and measure voltage at battery monitoring sensor C1689 pin 2 using the correct circuit connection points. If voltage drop is less than 0.5 volt, the path supports installing a new BMS. If it is not less than 0.5 volt, repair the wiring circuit. If the BMS fault is not present, continue to the vehicle ground voltage drop check. With the engine still running at idle, headlamps on, and the heater blower on high, measure voltage drop between the generator case and the specified negative lead location. The voltage drop should be less than 0.5 volt. If it is not, inspect and repair the engine ground, generator ground, or battery ground for corrosion. If the ground side passes, continue to command versus response testing. Now monitor the PCM GenVs PID. Use the scan tool active command to set GenVs to 14 volts. With the engine still idling, measure system voltage at the required point. The recorded battery voltage should be within plus or minus 0.5 volt of the PID. If it is, continue to the PCM supply voltage comparison. If it is not, go to the generator clutch operation check. With the engine still idling, headlamps on, and blower on high, measure battery voltage and monitor the PCM VPWR PID. The PID should display battery voltage within plus or minus 0.5 volt of the recorded battery voltage. If it does, continue to the PCM voltage supply circuit checks. If it does not, repair high resistance or loose connections in the affected PCM power circuits. Turn the ignition off and disconnect PCM C175B. Connect a 5 amp fuse jumper wire to powertrain control module C175B pin 83 as specified, then go COO. Measure voltage at PCM C175B pin 22, pin 23, and pin 43. Each of those voltages should be greater than 10.5 V. If they are, remove the fused jumper wire and continue to the PCM ground check. If they are not, repair the affected circuit or circuits. For the PCM ground check, measure battery voltage at the battery. With the engine idling, turn all accessory loads off and compare the PCM VPWR PID to battery voltage. Then turn the headlamps on and the blower on high and compare it again. The PID should read within plus or minus 0.5 volt of battery voltage with accessory loads on and off. If it does not, repair the affected PCM ground circuits. If it does, continue to the dynamic VPWR check. Measure battery voltage at the battery again. With the engine idling and accessory loads off, monitor and record the PCM VPWR PID. Momentarily accelerate the engine to wide open throttle and release. Repeat this 4-5 times while watching the PID. The PID should stay within 0.5 volt of the recorded battery voltage when engine RPM are increased. If it does, the system is operating correctly at this time. Inspect and repair any connector or pin issues you find, and if none are found, perform the battery drain check. If the PID does not stay within 0.5 volt, continue to the PCM connector and operation check. If the commanded generator voltage test did not match, turn the ignition off and perform the generator clutch component test. If the generator clutch is okay, check the generator wiring harness for looseness, corrosion, loose or bent terminals, and loose eyelets before installing a new generator. If the clutch is not okay, the path supports installing a new generator clutch. For the final PCM check, turn the ignition off, disconnect and inspect all PCM connectors. Repair corrosion, damaged or bent pins and pushed out pins as specified. Reconnect the PCM connectors and make sure they seat and latch correctly. Then operate the system and see if the concern is still present. If it is still present, check OASIS for any applicable TSB. If a TSB applies, stop this path and follow that TSB. If no TSB addresses the concern, the path supports installing a new PCM. If the concern is gone, the system is operating correctly at this time, and the root cause may have been a loose or corroded connector or pin issue. After the repair, keep verification separate from testing. Operate the charging system again, verify the repair, and confirm the code stays gone. The main takeaway on P0562 is to prove whether the voltage loss is in the generator output path, grounds, BMS circuit, PCM power and ground circuits, or the command versus response side before condemning a major component. For more diagnostic training, visit stepdiagnostics.com.